this lesson, we're going to look at the rate of change of linear equations. Now, the rate of change is a way of comparing quantities that have different units. In this example here, we have distance versus time, and what we want to look at is the rate of change. How much is the distance changing as time changes? So let's take a look at this. Now, you'll notice here we have 2 points. Our change in time, when our time changes, this is 1, this is 3, so our change in time is 2 hours. And you'll notice as time changes here, our distance has changed from 40 kilometers to 120 kilometers. So this is a change in our distance of 80 kilometers. That's our change in distance. So now we say here that our rate of change is 80 kilometers for every 2 hours. And this can be reduced to 40 kilometers for every 1 hour. And that is our rate of change. You'll notice this is the same thing as slope. Here we have our change in the vertical. So change in the vertical, in this case it's distance, divided by the change in the horizontal, which in this case is time. So this is really the same thing as slope. Our rate of change is the same as slope. Let's take a look at another example. In this example here, we have oven temperature versus time. And in this example, this is the oven heating up and how many minutes it takes for the oven temperature to reach a certain degree. So our time now starts at 0, it's in minutes, and it goes to 5 minutes here. So our change in time is 5 minutes. Our change in temperature goes from 50 degrees Fahrenheit to 350 degrees Fahrenheit. So this is our change in oven temperature. Change in temperature. And that's equal to 300 degrees. So our rate of change then is our change in temperature over our change, let's make that a better delta here, our change in time, and that's 300 degrees for every 5 minutes. Now we can reduce this here to 60 degrees per minute. And that's our rate of change, which again is the same thing as our slope for this line. Okay, let's look at one more example. In this example here, we have the liters of fuel in a fuel tank and compared to the distance in kilometers. So our fuel in the fuel tank is decreasing as our kilometers driven is increasing. So let's look at our change in kilometers here. So this goes from 20 to 120. So our change in distance is 100 kilometers. And our change here in liters in the fuel tank goes from 50 liters to 40 liters. So our change, we've called this N, number of liters, our change is 10 liters. So now our slope here is the change in N over the change in D, and we have 10 liters per 100 kilometers, or we can reduce this 1 liter per 10 kilometers. Now you'll notice that the slope here is negative. It is decreasing. As we read this from right to left, our slope is falling or going down. So our rate of change is decreasing 1 liter per 10 kilometers. So we say it is decreasing by 1 liter for every 10 kilometers. Now, if we were to look at just the slope for this, the slope is negative 1 over 10. That is the slope of this line. But when we're looking at the rate of change, we want to say that our rate of change is decreasing 1 liter per 10 kilometers. We don't put a negative in front of here. Instead, we use a word to say it's decreasing. And that is the rate of change for linear equations.